1.5 trillion micro and macroplastics and 210 million gallons of petroleum pollute our oceans each year. Currently, there are no widespread methods of removing microplastics and subsurface oil. We aim to fill this water purification void by examining environmentally friendly and cost-effective solutions. This study is the first to examine snail mucus as a bioaccumulator for pollutants.
We hypothesized that if snail mucus is introduced to polluted water containing motor oil and microplastics separately, then the mucus will remove the pollutants from the water. We chose these two pollutants due to their prevalence in the oceans and their different chemical properties. To conduct our experiment, we added microplastics, deionized water, and snail mucus in a 10 to 10 to 1 ratio respectively, and motor oil, deionized water, and a snail mucus in a 5 to 10 to 1 ratio respectively. This was added into a pipette and vortexed for 30 seconds. The pollutants became trapped within the mucus, which was then removed from the solution, creating a purified solution. The remaining water was then tested.
To evaluate the effectiveness of the mucus, we conducted UV-vis spectroscopy. This result indicated that 91.6% of microplastics and 69.4% of motor oil was removed. These results were statistically significant with p-values less than 0.0001. This was conducted using a student's t-test. To better understand how the mucus was able to remove these pollutants, we conducted a BCA assay analysis. This revealed the molecular composition of the mucus, which was 94.2% water, 0.3% proteins, and 5.5% other macromolecules. Further material analysis revealed that the mucus was insoluble in both water, which is a polar solution, and oil, which is a nonpolar solution.
This study was the first to successfully use snail mucus as a bioaccumulator. The results of the material analysis and the mucus pollutant interaction images indicate that the mucus was able to remove both polar and nonpolar substances. The results of the BCA assay indicate that the other 5.5% of macromolecules was likely largely composed of lipids. The presence of both nonpolar lipids and polar molecules within the mucus matrix may account for the solubility results. These findings highlight the potential of snail mucus to remove a wide range of pollutants from water, including potentially other oils, metal ions, and dyes. Further research should look at the material profile of the snail mucus to help identify other mucuses which may serve as bioaccumulators.
So why does this matter? In a time when there is more plastic than fish in the oceans and hundreds of thousands of organisms die because of oil spills each year, there's an urgent need for a natural solution with versatile capabilities and applications. Snail mucus's ability to remove suspended particles from water offers a promising solution for the world's growing problem of ocean pollution.